Hey folks, welcome back to the channel. Now that we've got the footings poured, the next step is going to be to strip the forms off since they've cured for about 24 hours. And then we backfill around them and then finish the excavation. And you'll see me and the contractor walking around a little bit out here, our general contractor, trying to make a decision as to how to address the problem of plumbing drainage. And this is another one of those things that I plan on doing a lessons learned video after this first stage of construction is over to kind of bring everybody up to speed and hopefully help you not make some of the mistakes we've made. But the gist of it is the septic inlet is too high for how deep these footings ended up in the ground. So we're working through how to mitigate this problem and get it so that our septic will drain from the house without having to put any kind of inline pump. But anyway, come along, watch us. We're going to be stripping these forms out and finishing digging this giant hole in the ground. We're going to take about another 200 yards of dirt out of the middle of this thing so that we can start the process of getting ready to put a slab on. I'm removing the cross braces on the top of this form, and the reason it's so difficult is because, as you saw in the previous video, we were waiting around for concrete to arrive and the concrete started curing. And then as they were finishing this pour, the form is actually a little low in this area, so the finished grade of the concrete is above the bottom of these cross braces, and they've cured into the concrete. And what the contractor that was doing this had planned to do was unscrew these and move them down in a series and fill and finish under where these cross braces are. Well, that didn't happen, and so now I'm having to knock these loose and kind of pry them out of a hole in the top of the footing here. Not too sure I'm going to have to do much digging on this side. If you'll just go down through there and take them loose, okay, I'll start pulling the boards off. in general, using these deck screws to hold the forms together has been really good way of putting them together, because it's easier when you're building them, and for the most part it's easier getting them out to strip the forms. The only downside is when there's concrete in the socket for the Torx bit, you know, then you've got to kind of clean them out a little bit and to get them to come on out. The bigger pain is all of the clay backfilled around these forms in an attempt to hold them in place and seal off the low spots on the bottom to keep them from leaking too much concrete out when we were filling them. Now, if these were braced with 2x against the sides of the trench, this whole process of stripping these out would be a lot easier. I'm having to go down through here with a pry bar and dig all the way around this footing inside and out to get these boards loose so I can pull them out. Another aspect of the way these forms are put together that's making the stripping process difficult is that there are several places where there's an inside corner that the screws holding the form together are screwed from the inside of the form to the outside. And if corner blocks had been used where you screw through the corner block into the form board from the outside of the form, you could then disassemble the whole thing from outside the form without having to peel sections off that are screwed together and fight with that to then pull the screws out and finish your disassembly. Now we're going to backfill around these footings with the same clay that we had to put underneath of it and compact the backfill to support these footings on the inside and the outside. And the reason we're doing this is because in addition to backfill under the footings compacted to 95% compaction, the engineers have specified that we have to do the same thing inside the footprint of the house under the slab. So since we're going to be putting a lot of stress pressing outward on the footing and then eventually on the stem wall that's going to have to go on top of it, when we do the compaction inside, we're trying to carry the clay up the outside as well to provide even pressure on that footing. I mean, you don't think so, but you're putting a lot of strain on this concrete when you compact all of this material inside of it, because all that's holding it in that vertical plane is going to be that concrete, and if you're not supporting it equally, you can crack these footings. The reason we're having to dig this center section out in order to then backfill it with this clay is there's about 2 feet of silty loam topsoil. It's not very good topsoil, it's not very rich, but it is topsoil with organic matter that's on top of a layer of what they consider to be expansive clay. And what that means is it absorbs water and expands, and then when the water is removed from it through evaporation or just migration within the soil, it then contracts. So it's considered to be expansive clay. And what we're trying to do is dig down through this silty topsoil and get down into the layer of clay, because even though it is expansive, it's more supportive than the topsoil. And then we're going to backfill with this non-expansive clay and compact on top of it. It's what the engineers have spec'd out, and unfortunately that's just what we're having to do. So I'm going to speed up this video a little bit and let you just kind of see the process of getting all of this overburden out of here, so that we can start getting ready to move on to the next phase. So here you can see the surveyor's back on site. Our general had him come back out because we need to mark the location for the corners on these footings. After our discussion over how best to solve the problem of our sewage drainage and the elevation difference between where the top of the footing is and where the inlet for the septic tank is, we came to the conclusion that the most cost-effective way to address the problem would be to add a stem wall to the top of this footing. We looked at moving the septic tank. We looked at basically abandoning that septic field and putting in another system lower down the hill, and the cost of both of those options was not enough difference to warrant going with that decision over putting a stem wall in. The house originally was designed to be slab on grade with a monolithic pour, and basically what that means is your footing and the slab and everything is poured at one time and it's on grade. Because we had to put the septic system in to satisfy the electric company to get power run to the site so that we could stop living in the driveway of our shop, we went ahead and put the septic in, put the well in, and started making moves to excavate the site. The downstream result of that is that the septic tank is too high to allow us to put the house on a slab on grade. You know, the net result, we may be happier because the house is going to be a little higher out of the ground, which is going to give us, you know, somewhat better views, but it's just a problem that we hadn't anticipated, that's something else that costs time and money. Alright folks, I think this is going to wrap up the footings phase, and we're going to get ready to move on to the stem wall in the next video. I want to thank you for watching, and hope you got some useful information out of it, and y'all have a good day.